Unit 3, Part 3, Writing Equations and Transformations of Rational Functions. Well, technically, this entire lesson is a review lesson. So we have talked about transformations of any function before. We've also talked about how to write equations. We did this back in the first lesson, but we just wanted to reinforce it and reiterate some of the skills to make sure that you're ready for any assignment that might pop up on this. Well, the main thing to remember here for any function, should there be a vertical stretch, we always multiply the number by the a value that was what multiplied the function by something. Well, in this problem, the a value is in the numerator. So if there is a negative out front or a negative in the numerator, this function is flipped upside down and reflected over the x-axis. If a was bigger than 1, there's a vertical stretch. If a is smaller than 1, vertical compression, just like we did with all the other functions. Well, this normally we said for the b value, that was in the parentheses next to the x. Well, in here, there's an understood parentheses. That's the whole denominator is the parentheses part. So if there's a number with the x, that is your horizontal stretch or compression. If it's bigger than 1, it's a horizontal compression. If it's smaller than 1, it's a horizontal stretch. If b is negative, it's reflecting horizontally, which means reflected across the y-axis. And then we still look at this c term to see whether it moves right or left. You just have to remember to do c divided by b. If c divided by b becomes out to be a negative value, it goes right. If c divided by b is a positive value, the function moves left. And that's moving your vertical asymptotes. And the d, which is the vertical shift, if it's a plus d, it goes up. If a minus d, it goes down. And that usually you look at your horizontal asymptotes for that. So let's talk about number 1. Do you see we have 1, 2, 3, 4, 5, 6 things I think happen to this one? So is this one reflected? Well, there's a negative out front or in the a term. So it reflects over the x-axis. There's also a negative with the x term, so it reflects over the y-axis as well. So we can say reflection is over both the x and y-axis, over x and y-axis. Okay. And is there a vertical stretch or compression? Well, let me erase my scribbles up here already. Since the a term, ignoring the negative sign because that was the reflection, that 3.4 is bigger than 1, so it is a vertical stretch. So we're just going to say stretch. And horizontal, we look at this number, ignore the negative sign because that was the reflection. The 1/5 is smaller than 1, so that is a stretch. On horizontal, it's backwards from what you think. It's a stretch if it was less than 1. If it's bigger than 1, it was a compression. And 1/5 is smaller than 1. Now, the transformation, we have to take c divided by b. 10 divided by a fifth. And technically, you can go put the negative if you want. When you divide by a fraction, you flip it and multiply it by the reciprocal. So that's 10 times -5, which is -50. Since it's negative, it goes to the right. So it goes right 50. And the vertical transformation is this d goes down 7.2. So down 7.2. Oh, I forgot to put down. So we'll say arrow pointing down. And the domain would be everything except the vertical asymptote, which our vertical asymptote, we take 1/5 x plus 10 equal to 0. All right, so we already calculated this 10 divided by 1/5 was 50. So everything besides, it moved right 50. So everything before 50, negative infinity to 50, and then 50 to infinity. And this one moved down 7.2, so our horizontal asymptote was at 7.2. So it's everything below 7.2, and it was down, so it was a negative 7.2. And then everything above that negative 7.2. And there's this entire function for all our traits. Let's repeat the process. Now this one, I stuck the constant term, out front. So that is a positive 9.2. So that's usually the first thing I would do is write that there. And if you want to put the negative up there, that way we know, yes, it's reflected over the x-axis because of this negative and reflected over the y-axis because of that negative. So reflected over both, over x and y-axis. And y-axis. Okay. Now, we look at the number in front of the x, which is factored out on this one. Oh, so sorry. I was jumping to horizontal. Let's do vertical first. Vertical, this number right here is 0.8. That is smaller than 1. Don't worry about the negative. The negative is the reflection. So since that's 0.8 is less than 1, it is a vertical compression. And then I'm going to erase all my markings up here. So I did leave the negative. The 9.2 I can leave covered up because I put it at the end. So here is what I have right now. Okay, so is there a horizontal stretch or compression? The number, if this were to be multiplied in here, it would have been a -6. So the negative is the reflection. So 6 is bigger than 1. So it is a compression also. It's backwards. Horizontal compression. And the amount would have been 1/6. Horizontal compression of 1/6. This one was vertical compression of 8/10, or 8/10 is 4/4. Back on this last one, I never put what the amount was. This was a vertical stretch of 3.4. This was a vertical stretch of 5 because it was a reciprocal of 1/5. The horizontal one, you take the reciprocal to get the value. Now, the horizontal transformation, if it's factored, that's your horizontal transformation. If it's not factored, then we have to take this divided by this. But if it's already factored out, they've already done that for you. So 1/36, then it was a 1/36, but there was a negative out front. So let's see. Hold on. 1/36. If you, it almost helps me if I multiply, just to get less confused here, if I multiplied it back in. So if I multiplied it back in, just to talk about this one, that would be -6x for this term, and be a -6/36, which is negative. It'd be a -1/6 there. So this is a negative divided by a negative, which is a positive. So that means it moves left. And it was 1/6 divided by 6, or this value right here is 1/36. And then the vertical, we know it went up 9.2. 9.2 up. So the domain is everything besides my horizontal transformation, because that's where my vertical asymptote was. So everything before, and if we went left, that's a -1/36. So everything before -1/36, and everything after -1/36. My vertical, let's see, this shifted up 9.2. So my range is everything below 9.2, comma 9.2, and everything above 9.2. Okay, let's move on to number 3. On number 3, we're going to do some of what we did on the last set of notes. We need to find the x-intercepts and the y-intercepts. Well, this problem, and where the holes are, the vertical asymptote. So it's a combination of everything we've done in the previous, when we're on lesson 3, on the previous 2 lessons. So the first, let's factor the numerator. That what multiplies to be -4 that adds to be -3, that'd be 4 and 1. To get -4, and that means one's positive, one's negative. To be -3, the bigger one's negative, the smaller one's positive. On the denominator, we have what multiplies to be 3, and that'd be 3 and 1. So x plus 3 and x plus 1. So I see x plus 1's divide out. So that tells me there is a hole at x plus 1 equals 0, which means x equals -1. I don't need an x. Oh, I didn't mean to do that. That was x equals -1. So I almost did it again. -1, but that's not the whole. I need the y value also. So this was x minus 4 left on top. This was x plus 3 and 1. The ones canceled. So x plus 3 on the bottom. I'm double checking myself since I didn't want it. If I undo it, it messes up my screen. So x minus 4 and x plus 1, and then this was x plus 3 and x plus 1. So yes, those canceled out. They're divided out. So we had a function that simplified down to x minus 4 over x plus 1. So to get the y value, plug -1 into the reduced version. That would be -1 minus 4 in the numerator, -1 plus 3 in the denominator. -1 minus 4 is -5. -1 plus 3 is 2. So this is -5/2. Okay, we have our hole. We look at what's left in the denominator, and there's our vertical asymptote. The vertical asymptote is x plus 3 equals 0, which means x equals -3. The horizontal asymptote, it has the same degree on top and bottom, and we can use the reduced version. You can also look back here. And since the degree is the same, that's the bottom equals the top, we look at the coefficients. The coefficients are 1 divided by 1, so y equals 1. And if there's a horizontal asymptote, there is no slant asymptote. So, to get our domain, it is everything except the vertical asymptote and the x value of the whole. So everything before -3, so negative infinity to -3, everything between -3 and -1, -3 to -1, and then everything after -1. To get the range, we go down for everything except the horizontal asymptote in the holes. So the horizontal asymptote is at 1, the y value is at -5/2. So everything before the smallest number out of those two is -5/2. So everything before -5/2, everything between -5/2 and 1, and then everything after 1. Now to get the x-intercept, we make y 0, take the reduced one here, and just set that top equal to 0. X minus 4 equals 0 means x equals 4. Y was 0. To get the y-intercept, you can plug in 0 in the original for all the x's, or even the reduced one. If we put 0 there and 0 there, you get -4/3. So it's 0, -4/3. We could have done that one a long time ago. That one's easy. Okay. Let's move on to number 4. For number 4, let's see. I see the degree is bigger on top than it is on bottom, so there is no horizontal asymptote. So to get the slant asymptote, we're going to do division. But I'm not ready for division yet. Let's do some factoring and canceling. On the top, I notice I can divide out an x. That's going to be x times 3x squared minus 10x plus 3. And the bottom factors to x minus 3 and x plus 1, because it had to multiply to be -3 and add to be -2. Well, the top, I'm going to temporarily multiply the 3 to the other end and make that my scratch work at x squared minus 10x plus 9, which factors to x minus 9 and x minus 1. But we have to divide by 3. So that means we still have this. If I factor this, I have x minus 3 was one of my factors, and I have 3x minus 1 is one of my factors. And my denominator is x minus 3 and x plus 1. Okay, so I have everything written. I notice that I can cancel out an x minus 3. So there is a hole at x equals 3. To get the y value, plug 3 into the reduced version. So what do we have after we reduce this? After we reduce this, we have x times 3x minus 1 over x plus 1. Okay, if I plug 3 into that to get the y value, 3, and that would be 3 times 3 is 9 minus 1. 9 minus 1 is 8. And 3 plus 1 is 4. So that's 24 over 4, or 6. So 3 comma 6 is my whole. Now, the domain, I look for any vertical asymptotes. I do see, to find a vertical asymptote, I look at what is left in this denominator after I've reduced and factored and canceled. So I have an x plus 1. So x equals -1 is my vertical asymptote. To get the slant asymptote, I'm going to take this, you take the reduced version that we already have, and if I multiply that back out, I get 3x squared minus x. So I'm going to do division, and you can do synthetic or long division in this with this one by x plus 1. I don't want to do long division, so I'm going to do -1. X plus 1 equals 0 means x equals -1. So I'm going to do synthetic division with -1. My coefficients for the x squared go first, the x term go next, and the constant goes last. And there wasn't a constant, so it's a 0. So we bring down the first term, that's a 3. Multiply that and put it under the next term. Multiply that by what was out here, and that becomes -3. Add those and bring it down, you get -4. Multiply that and put it under here, and that gives us 4, but we don't care, that's the remainder. This was x squared, so this is x. So we end up with y equals 3x minus 4. Y equals 3x minus 4 is our slant asymptote. Now, let's look at Where's my reduced version? My orange is my reduced version. So this is what I'm going to refer to for my x and y intercept. To get the x-intercept, make y 0. Means you can set the top equal to 0. And if you set the top equal to 0, you get 0 and 1/3. So we're setting top equal to 0. So 0, comma 0, which means I also know the y-intercept because both of those are 0. And then also 3x minus 1 equals 0. 3x minus 1 equals 0. You add 1 and divide by 3, you get 1/3. So there were two x-intercepts, but only one y-intercept. And the domain is everything except any vertical asymptotes or holes, or the x value of the hole. So the domain, let's switch colors one more time. The domain, let's see, we had a vertical asymptote at -1 and a hole at x is 3. So our domain is everything besides -1 and 3. So -infinity to -1, unioned with -1 to 3, unioned with 3 to infinity. And when there's a slant asymptote, we will not worry about the range. Okay, I think we have covered everything we need to on the front side. Let's practice the same process on the back. So moving on to number 5, and we're going to sketch a graph this time. So we need to know where the holes are, if there are any. And let's see, can I factor this function? I have an x squared plus 6x plus 8. That factors to what multiplies to be 8 that adds to be 6, 4 and 2. So x plus 4 and x plus 2. Okay, and divide by the x plus 4. That means this function had a hole at -4. I don't know what the y value is yet, but I know what the x value is -4 because that's what canceled out. We're left with just a graph of x plus 2. So when x is -4, if we plug -4 in here, -4 plus 2 is -2. So -4, -2 is the hole. So -1, 2, 3, 4, -2. This graph has a hole. The rest of the graph just looks like the reduced version, x plus 2, which is a line that had a y-intercept of 2 and a slope of 1. Down one, back one, down one, back one, down one, back one. There's a hole, down one, back one. And so we can draw that line in, and it keeps going. Okay, so which means this graph never had a denominator left over, so there's no vertical asymptote. So we can say none or NA, whatever you want to say. None. It never levels off. There's not a horizontal asymptote. It does have a slant asymptote. It is the slant asymptote. There's what the slant asymptote is. Y equals x plus 2. It follows that line the entire time. Yeah, that's all we need on that one. To find that algebraically, if we took the original function on this one, we could have said, taken the coefficients 1, 6, and 8, and did the synthetic division by -4, because x plus 4 equals 0. 1 times -4 is -4. You get a 2. 2 times 4 is -8. You get a remainder of 0. That's 1x plus 2, which is exactly what it reduced to. So that is number 5. Now let's do number 6. On number 6, this is a difference of 2 squares. That is x squared minus 4 and x squared plus 4. Oops. Now, the denominator is x squared minus 4. I could go ahead and factor those farther, or I can notice that those x squared minus 4 factor out, so we can divide out. So we're left with just x squared plus 4. There's no denominator left over, so there is no vertical asymptote. The degree on top was bigger than the degree on bottom. There's no horizontal asymptote. The degree was actually 2 bigger on top. There'll only be an oblique asymptote if this degree was 1 bigger than that, so there's no slant asymptote. We're left with the graph of x squared plus 4, but yes, there was a hole. Now, there are actually 2 holes, because if we set the part that canceled out, x squared minus 4 equal to 0, you get x equals positive and -2. So that means there's a hole at -2 and a hole at +2. To get the y value, plug those into the reduced version. If I plug in -2 here, -2 times 2 is 4. -2 times -2 is 4. Plus 4 is 8. If I plug in +2, you get 2 times 2 is 4. Plus 4 is 8. So this function, the reason it had 2 is because this is the graph of x squared plus 4, which is a parabola that moved up 4. So that's what the graph looks like. The only catch is it has a hole at over 1, 2, up 1, 2, 3, 4. A hole at 2, 8 and -2, 8. To draw a parabola from the vertex, you go over 1, up 1, over 1, up 1. Over 2, up 4, we just talked about was the hole. and then over 3 up 9, but it doesn't fit on our graph. So it's just a graph of a parabola with the hole at those two y values. Okay, last one. Maybe if I can get my screen to scroll. Oops, got the screen scrolled and realized I lied to you. It's next to last one. So to write the equation of this one on number 7, step 1 I would look for is, do you see any horizontal or vertical asymptotes? I see a vertical asymptote at -2. And I see another vertical asymptote at +1. So that means my denominator needs a -2, which means an x plus 2 in the bottom. It needs to be undefined when x is -2. And also when x is, what do we say, +1. So that'd be x minus 1. I do not see any holes in the graph, so there's nothing that cancels. So the next thing I look at is, does this graph have a horizontal asymptote? And I see a horizontal line at y equals 1. So we had a horizontal asymptote at y equals 1, which means the degree on the top and bottom had to be the same. Well, that means we need two x terms. Since we had an x squared on bottom, we need an x squared on top. So I know there's at least two different values of x. And the leading coefficient is 1. So there's no other extra a number to worry about. So now I just have to figure out, how can I find those two values? Well, if you remember on the last lesson, we talked about the x-intercept was when y was 0. Well, that's when the top would be 0. I see an x-intercept at x equals 0 and another x-intercept at x equals 4. There's your factors on top, x and x minus 4. That would make the top 0, so that's the two factors we need. And I don't need a parentheses around the first one, but I can rewrite that as x times x minus 4 over x plus 2 and x minus 1. Or they might want the answer multiplied out, which would be x squared minus 4x. And the denominator would be x squared plus x minus 2 if we FOIL that out. So either version is correct. Okay, now we're down to the last one. So for the last one, we're going to do the same process. We're going to write this function, and I do see a hole. I see, oh, and I even labeled, I was nice enough to label it for you. The hole was at -1. So there's a hole at x equals -1. X equals -1, which means I have if I move that -1 the other side, I have an x plus 1 on top and bottom that has to cancel out. And I see a horizontal asymptote at -2, it looks like. So I need a -2 out front. And now let's look at, is there a vertical asymptote? I do see a vertical asymptote at +1. So that means x minus 1 has to be on bottom, because it had to be a 0 on bottom. And then, do you see an x-intercept? I see an x-intercept at 2. That means there's an x minus 2 on top. And that's the horizontal asymptote. We have everything we need. All we got to do now is clean it up. So if we FOIL the top, I'm going to leave the -2. I'm going to FOIL this. You get x squared minus x minus 2. And the denominator, you get x squared minus 1. And then if I distribute the -2, we get -2x squared plus 2x plus 4 over x squared minus 1. And that is our function. So we can say f of x equals, and I never said f of x equals on the last one, or whatever variable you want to use for your function. Okay. Well, there's everything we need for this lesson. Good luck to you.